triangulation. Now we're looking at similarity. Last lesson we looked at using sine and cos rules to be able to find the triangle that we needed. So now we're up in the game and we're saying we're going to use similarity. So we're now using the stuff from geometry and applying it again in real life situations. So you need two corresponding lengths to establish a scale factor. Do you remember what the scale factor was?
Yeah.
How did we represent a scale factor?
Okay.
K. So you need to remember scale factor K. How did you find the scale factor?
The image over the original.
Yep. The length of the image over the original.
Was this in geometry?
This is in geometry. Chapter 7.
Oh, 7.
So that's something you should have remembered from the last lot of exercises that we did. Okay? So this is where maths all comes connected. You guys think everything's separate. It's not. It all comes back to haunt you again. Alright? So you need the two lengths to establish a scale factor between the two similar triangles. A second accessible side will be used to scale up or down the corresponding inaccessible side. So in other words, you need one more side. Once you know that measurement, you can use that, when you're ready, you can use that to then find the side that's the unknown. So if they tell you find the length between A and B, with all the other measurements. Okay, that's what you're using now. So you've got to remember that with similar triangles, there are 3 rules. Any one of them can be used to find what you need. A. Angle, angle, angle. All the angles are the same. Doesn't matter the size of the triangle lengths, all the angles will be exactly the same. Side, side, side. All the corresponding sides have the same scale factor. Side, angle, side. So you've got 2 sides with the same scale factor with a corresponding angle that is exactly the same. That is what you're looking for. So here we have an example. We have a 1 meter ruler that's 0.3 meters from a point. Using that scale factor, we want to find, or using that triangle I should say, we want to find a scale factor to find how tall the actual cypress tree is. Now, have you got enough information to do all that?
Yeah.
Okay, so Brendan, what was your question going to be?
No, not question.
Don't give me an answer yet.
Okay.
Now, let's work through this together. What have you got? What is it that you've got?
Side angle side.
Side, angle, side. We've got a side, and this angle stays the same because you've got a little triangle here that's attached to a bigger triangle. Okay? So you've actually got everything there. So if you want, you can always redraw it again without pictures. I won't use red. You've got your little triangle, which is 1 meter by 0.3 meters. Obviously, my drawing's not to scale, especially when 0.3 is much larger than 1. Then you've got your second triangle, which has a 4.6 meter length.
And it's X length.
And where's the X length go?
On the side.
On the side here.
On the opposite.
Now, these 2 angles are obviously the same. They're both right angle triangles.
So they both have 90-degree angles.
So we've got enough there to start working on a scale factor. So we would use the side angle side. So using side angle side, we can find a scale factor to use to find out our unknown length. So what information am I going to use for my scale factor?
You're going to use
4.6.
over 0.3. Yeah.
So we're going to use
4.6.
4.6 divided by 0.3. And that's going to equal to, so this is the image over the original. So then our image here will be x over.
15.3.
Oh wait, we don't want to do that there. Sorry. This is still our k. I apologise for that.
15.33333.
15 point.
3333333.
I'm going to go 15 and a third. Because it's the 3 recurring, we'll just go with the third to be safer. So, we know our scale factors 15.
Sorry, what's that say?
Side, angle, side.
Oh, okay.
If you listen and don't talk, you'll know this. So, using our scale factor, so has our image, has our object increased in size or decreased in size? Increased. We've started with a smaller measurement and we've increased by 15 and a third. So, now, how am I going to find this x?
Multiply 1 by that.
So, our new scale factor will be x over 1. The image over the object. We know that our k for our scale factor is now 15 and a third. You want to get the x by itself, what are you going to do?
Multiplied by both.
Multiply both sides by 1. So what's 15 and a third multiplied by 1?
15 and a third.
Stays the same. So our height of our cypress tree is what?
15 and a third.
15 and a third metres. Or you could go as 15.3 for 1 decimal place because our question has 1 decimal places in it.
So what do? You just do x equals.
Because we multiplied by 1 on both sides. And they cancel out.
So that's just obvious, that one.
That one's obvious because it's quite simple. So the cypress tree is 15.3 metres tall. That's it. That's all you need to do. Similarity is not hard. It's just a little bit time consuming to make sure that you've got the right information to move on. Because you've got to prove it. You've got to say that it's side angle side. And this is how you show it. K represents scale factor.
So
They're the same thing.
So your original equation is 15 and a third is equal to x over 1.
Yeah,
And then you times each side by 1.
that's right. So we replace the K with the 15 and a third.
Yes, what if it was asking you to find the height from the ground to the ruler?
That's.
So if they gave you the height of the cypress tree and they asked you to find the ruler,
To go backwards.
go backwards. So if we wanted to go backwards, I need space. I'm going to rub this off.
Well, wouldn't you just use. Wouldn't you just use.
Alright, now, shh.
Because you're not given the height.
No, you're not using trigonometry. So if say, from a point,
Why does everyone have to be happy?
you don't want to make someone sad when they're doing maths, it just doesn't work.
Well, it doesn't make people happy.
That's really not the scale.
Just for those who have issues.
Now we're just wasting time.
Where's her hair?
Her arms look like
Got
she
cancer
speaks
break.
off the tree.
Because she has one like bigger hand and one with the leg.
Look, shush.
She had a stroke, okay?
I'm a mathematician, not an artist.
It's a
Get over it.
drawing is.
You're not sure if it's smile or a hook.
I don't know if this is mathematics.
It looks like Chris Judd smiles.
Guess
Yeah,
what
he
she
smiles.
smile with?
Right.
Oh, didn't bring me.
I'm
Can't hear.
If you're going to criticise my drawing, this is what I'm doing anyway. So, now, what happens when it's the other way around?
It's annoying when
Now,
people say
what happens when it's the other way around? Not much.
You gotta make it smaller.
It's still the same process. Gentlemen, when you're ready. Okay. So the process isn't all that much different. You've got your object and you've got your image. So your scale factor, you worked it out exactly the same way. So now we're going to say if I'm going from a larger measurement down to a smaller measurement, how's it going to be affected? Obviously, what kind of a scale factor number are you looking for?
Less than 1.
Less than 1 because it's shrinking in size. Here we went up in size, so our number was greater than 1. So the moment that your scale factor becomes less than 1, even if it's 0.99999, it's still less than 1. There is still a reduction in size. That is what you're looking for. So here, the scale factor is the image over the object. So I end up with 1.6 over 5.
No.
Wrong length.
Yeah.
Over x. That's what we're going to find.
Why wouldn't your scale factor be 5 divided by 0.4?
So now we're going to go, that's what we want to find. But now we need to also find out this one here, so that we can find this.
So 0.4.
So we're going to go with scale factor of 5 over 0.4.
Wouldn't it be 0.4 over 5?
No.
For the way that I've written my scale factor formula, it's not. If I had written an object over the image, it would have been a negative number. A smaller number. I've written it backwards. As long as you're consistent the whole way through, you'll end up with the same answer. So, what's the scale factor there? 5 divided by 0.4.
12.5.
12.5. So we started from here, we grew to here,
So start from the bottom, now we're here.
right? So now, we say that the scale factor is 12.5. So 12.5 is equal to 16 over x. So 1.6 over x. Swap the x and the 12.5.
1.6 on 12.
So x is going to be equal to 1.6 over 12.5. And what is the distance of this block? We'll call it a block.
Blue.
So what's that value become? I'm waiting for someone to
So
come
what do
in.
you do?
So what I've done is I've swapped the x and the 12.5.
So can I just say, like, what if someone sees that and they do times 1.6? Like,
So,
why would that be wrong?
if you're not sure about the step that I've done here, what it is this. 12.5 is equal to 1.6 over x. How do you get the x by itself? The x is on the bottom, it's an issue. So multiply both sides by x.
0.128.
Oh yeah, I got the answer.
So 1.6 is equal to x times 12.5. Get the x by itself. Divide by 12.5.
Yes.
So x then becomes, what was that calculation?
0.128.
0.128. So we'd say that the block
0.1.
is 13 centimeters tall.
How do you get 13 centimeters?
Was she times?
Oh, yeah, duh.
Oh,
So the measurement was in meters. Rather than saying that it's 0.13 meters, change it to centimeters so it's a more nicer number. So it's 13 centimeters tall. Sorry?
It's just it's not fucking hard.
No, I changed it to a block because I realised it's going to be quite a small number. Okay, so
that's one tall person. No, actually not.
I'm about 1.6,
Yeah,
so it's
that's
not
actually
that
Nah,
tall.
it's not tall.
Okay, so
If you wanted to do 0.4 over 5 and then times it by 1.6, would that be alright?
yes,
So 0.4 by 5.
times 1.6. You should come out with the same answer. Any other questions about what I've done on the board? Something that might not make sense?
Sarah, it's easier.
Yeah, it is.
Hound, sorry. Shh. Yep.
Do we write, like, anywhere around, do we write what is, or do we write
you'd say approximately because you've done rounding. So you want to write the true answer, and then in your sentence below, it's approximately this. Remember, worded question, worded response.
Alright, next.
All done?
Yeah.
So
Done.
what's the difference between doing that
So-
now and what we did last time? Is that because
Last
last time we
lesson-
didn't do
Last lesson we did the sign.
not lessons. Last time we did similar triangle.
Nothing different. It's exactly the
Oh,
same. The
just
difference
last-
is
we're
this
doing
is
calculation.
real situations. The last one that we did was
so
just
this is application.
questions. This is the application of it. All right, ladies and gents, get
Oh,
working.
see, last time we were
The
just
sack
getting the
is gonna be
scale
full
back.
Thanks for watching.
application.